I hope you all of you are safe. Nothing happened during the class time. So because we assume you are in the campus tomorrow. Tomorrow 9 to 11 you should be in my class tomorrow. So yeah, if you do something caught by police, I don't know. I will not admit what you do. At least technically you should be in the class tomorrow. Okay. Take this assignment and let the new student know. Ivan or Ivan here? Ivan is here. Shafiq, beritahu Shafiq lah. Okay. So just a refreshment for your complex number. Okay. So complex number, basically today we learn base of 2, base of 8, and hexadecimal. Maybe not inside your previous syllabus. Maybe hexadecimal is a bit new to some of you. But octet, binary, decimal is power of 10, the 10 base system. So then we do some conversion during the thing. Okay. Right. So these are the textbook that we use. Okay, we are now in chapter 2 already. So we will look at binary system, octet system, hexadecimal system. Okay. So this will be the chart for the 4 system that usually we'll use for engineering. Decimal number, that is what we usually very familiar with is base of 10. Like normally what we use 0 to 9 nowadays. They are base 10 numbers, right? Then binary number means they are in the base of 2. They are very useful when you do programming or when you do circuit design later on. Because in the circuit, electronic only can see on and off or 0 and 1 only. So most of the old system, they are used based to coding. Nowadays we are more advanced. We use hexadecimal. Octet number means octet itself is a Greek word. So it's a base of 8. Means we only use 8 numbers. We only eight not 8 numbers, 8 digit, which is 0 until 8. 0 until 7, sorry. 0 until 7 only. Okay. Then hexadecimal number is 16. We use 16 number, which is 0 to 9, and then A, B, C, D, E, F. Okay. 0 to 9. Number 10 is A. 11 is B. 10 until F is 16. So this one, hexadecimal. If you watch some movie, the Mars movie, Martian, when they lost in the Mars, then they use the communication using hexadecimal number. There's a scene that they use a hexadecimal number. If you watch that movie, okay. So this one basically more in the space communication and so on, because you have so many alphabet that you need to represent. All right. Okay, so these are the system that we use. Okay. This is the oldest calculator. They call it abacus, right? In Chinese, we call 算盘. Okay. Okay. Even some of the now latest what called 心算 this one is called what? Speed calculation. So that one also, they actually in their mind they play with this one. Okay. Then another one is another more advanced machine with this got digit in the hole here. They call Pascal machine. Yeah. So this is just some backgrounds. So in computer, we call them by bits. Megabyte. Bit is something part of the megabyte. So bits is a binary digit. They use the word BI and T, and they combine as bit. So in computer, they only look at 0 and 1. So this one you see in the Matrix movie. Then they only play with 0 and 1. So let's look at binary number. Okay. Binary number is basically based on 2, only use 2 number to represent something, 0 and 1. Okay. Okay, so this is some info lah. You won't see this one in test one. It's just info. Info. Okay. Then introduction to another one, octet. Octet is this one, like what we've seen just now, octet. And there's this one. Octet is a base of 8. So they call 3 bits. Or 3 bits. Today we'll be talking something like computer science, that tone, that direction. Okay, octet number 0, 7, and so on. Hexadecimal, U base 16 number represent 4 bit. Okay. So 2 bit, 3 bit, and 4 bit. 2 bit, base 2, base 8 is 3 bit, base 16 is 4 bit for each unit. Okay. Right. Yeah. So this is a basic introduction. What does the 0 to 9 mean? And A to F means 0, 9 is a normal 0 to 9 number. But the 10 we use alphabet to represent 10. A equal 10, B equal to 11, and so on until 15. So it's like 0 to 15. Then we will show you how it mix and become a meaning of something. Okay. Okay, binary. A quick one. Binary is basically we're playing with this power of 2 that I already put inside the handouts. So you start with the one on the far right is 2 power 0. 2 power 0, anything that power 0 means 1. Okay. Then you move on to 2 power 1, 2 power 2, 2 power 3, 2 power 4, and so on. Okay. So there's a meaning of each base of 2. So for example, 2 power 0 is 1, 2 power 1 is 2, 2 power 2 is 4, and so on. Okay, so it means something. It means something. So yeah. Then if you see this code, let's say if you see this code 10010110001 in base 2. In base 2 means how we write in base 2, you will see something, a small digit of 2 number below the number there. That is base 2. Okay, so how we convert into a decimal number with its power of in the base of 10. So you start aligning with the position. We start aligning from the far right. So far right, if it is 1, then you take this number. 0 means do not have this one. 0 means don't have 2 power 2. But if you see 1 means you have 2 power 3. You convert 2 power 3 equal 8. And you have 1 means in this position 0, 1, 2, 3, 4. So 2 power 4. Then 2 power 5, 0. And 2 power 6, you have 64. So you add up all those have 1, 1. Okay. So for example, it's safe you calculate from the last side, from the back, or you can calculate from the front. It depends on your style. There's no fixed way of calculating, but the general idea is to add up all the base 10 numbers. So here you have 64 plus 16 plus 8 plus 1, like this. Okay. Then you add the number 89. So how you write this representation in the test means you write the question 10110012 equal 89. If there's no number under there, means we assume it's a decimal number. It's a base 10 number. Of course, you put a small 10 below there also correct, but no need to do so. Okay. So we start to look at some numbers that are read by the computer. So let's say you have a decimal number of 234.5. How you convert this one in the base of 2? So it just means this one is in the base decimal number. So this is 234 and 5 and so on. Right? So this is in base of 10 decimal format. Right? Decimal format. So you're quite familiar. Then we put into decimal number. Right? We put into decimal number. Okay, so let's say in a base of 2, 1101.1 base 2. What does the 1101.1 base 2 mean? So you need to pull out this small table. You need to write on your sketch paper. You start with 2 power 0, 2 power 1, and so on. So this table won't be given. It's just that we assume you know how to write this one, how to build this one. So, and then you count. So this one is -1. This one is 0, 1, 2, 3. So you start to write. The first digit is 2 power 3. Then this one is 2 power 2, 2 power 1, and so on. Okay. So this one is 1, 0, and then 0.1, it means 2 negative 1. If you learn that the index number 2 power negative 1 means what? 1 over 2. 1 over something. If you have minus something, power minus something, means 1 over x. Yeah. Right. So this is how you convert the meaning of the number 1101.1 base 2 into this kind of meanings. This is in your brain, but a more proper way is to you calculate. You write this one equal this one, and then equal this one. Then you press calculator, equal to 13.5. Okay. So important that is for binary number, you understand this small table here. A small table and then location of the number. So for the previous, maybe your SPM time or your foundation time, you don't involve with 0.1 number. You get a full number. But for our bachelor degree level, we start to have point something. So what happened if you have another one behind here? It will be 2 minus 2 and so on. Okay. Okay, so this is the final answer. You should write like this in the test. If you are given this number in base 2, you solve by second line, third line, and then you write your final answer like this. Okay, copy the question, equal 13.5 base 10. Although you do not write 10, also I'll give you correct lah. Okay, this is just a quick revision for you guys. Okay, let's look at one good example. If you understand, we go very fast. So decimal number to convert 101102 base 2 to a decimal number. So basically you just build the thing. So maybe I give you 30 seconds, try to solve this one. So by looking at this table, okay, already also give you this table in your handouts. So you just count. This one have no decimal number. Have no dot number. So 0, 1, 2, 3, 4. So you only need to count until 2 power 4. So 2 power 4, 16 plus 8 plus 2 plus 1 equal 27. So you write like this. This is your test 1 or final exam kind of standard answer. For chapter 2, you write 101002 equal how many of 2 power something? Add all together. Okay. Of course, a proper way you need to use the bracket lah. But at this stage, we just keep the state. Okay, you write like this, and then you convert into the decimal number, means power of base 10, then is equal to 27 base 10. Any question? Any question? Anyone you are lost? Just no, huh? Okay, if you understand this one, the rest I just you go home and look at my slides, huh? Okay. Okay, fraction. Yeah. Okay, fraction means this is example. The further you go to the right means -1, -2, -3, -4. Like this. Okay. Nothing complex lah. And then in this module, you can put in the fraction format, or you can put in the digital decimal places format. Okay, minimum 3 decimal place in your answer. But if you have 4, then you give 4 lah, 4 decimal. Okay. Okay, so this is maybe something new to some of you lah. Okay, all right. So this one you know already. I skip. Okay, so this is your exercise. I give you answer here, but I want to see the steps in your attendance record lah later. So you can check yourself whether it's correct or not. Okay, I want to see the steps. So this is the first exercise for your attendance record. Okay, so we want to convert from base 10 to binary. Just now is from binary to decimal. Now we want to reverse. If you are given a decimal to binary, how do you find the number? So this is the trick lah. If you want to convert something base 10 to binary, you divide by 2. You take that number, divide by 2. Okay, now for example, this like this. If you are given 39 base 10, turn to binary, you just divide by 2. You divide by 2, so like 39 divided by 2, you get 19. But you have a balance of 1. Balance of 1, you just put beside the number. Okay? You just put divide number, divide until you get 0 or until you get 1. You don't need to complete until 0. As long as you divide until you get 1, you can stop already. Then after that, you read from the bottom to top. You read the number from bottom to top. Again, in the test, you can stop at 1 or you can stop at 0 based on your preference, right? And the important, you give me the correct number, correct answer. So in this example, you read from bottom 100111. The answer is 100111, and then at the bottom there, remember to put a 2 there. This. This is the answer. So in the test, if this one come out, you need to show me these steps. You don't need to write the remainder lah. I just want to see you know how to do this one. Yeah? 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 Good, If you cannot understand this, raise your hand and let me know. Okay. Then in some textbook or some lecturer, they like to use the most on the left, they call it least significant bit. And the one on the right is least significant, most significant bit and least significant bit. Okay? Because as you move towards left, the number become bigger and bigger. So it become more significant, right? Understand? Understand? Then we move on. What happens if you have fraction just now? You have something divide something. So what you do? You multiply 2. So don't confuse between the step lah. So let's say you have 0.625 base 10. You want to change to binary. This is point something. Point something, you need to multiply. If you ask you to change point something base 10 to binary, you just multiply the number by 2. So for example, 0.625 multiplied by 2, you get 1.25. You see one already maintained, pull the remaining 0.25 to here, continue to multiply 2 until you see 1. Okay, until you see 1, then you read from the top to bottom. Okay, so the answer for this one will be 0.1. This one, because this is a decimal point something. So this one is, you need to put 0.101 base 2. The answer is like this. Careless mistakes is this dot. Some of you might forget this dot during test. Your careless mistake, you might miss out this dot here. Yeah, this is how you do. Okay, so if you get a full number, you want to convert binary, you divide 2. You get point something, you multiply 2. Yeah, so this is 0 something. What happens if you have positive number and decimal place behind? You need to do these 2 steps. Okay, I'll show you. So this is, you understand already how to get this one, right? Okay, so this one also you understand. What happens if I combine the 2 numbers? Okay, you work until you reach 1. Okay, what happens? You get this number. 58.3125 base 10. You need to do 2 steps. You need to separate into full number and decimal number. You need to do 2 steps. So I show you the step. So the first part, full number one, you divide by 2. The decimal one, you multiply 2. Okay, 58, you divide until you get 1. Then you read from bottom. 10110. Then base 2. Continue with this here. 0.83. Okay, is it? Okay, 0.3125 multiply 2. Multiply 2 until you get 1.000. Okay. Then remember to join these 2 answer together. Okay. So 58.3125 base 10 equal 111.010.0111012. Okay. Okay. So at the end of the chapter, basically we are referring to a table. Okay. So this is your second exercise for your attendance. The answer is here. I will upload these slides maybe tomorrow or Saturday. Right? Any question for the conversion? No. Okay. Now, what happens if we add the number? Right? We add the base 2 number, addition. How we do? We will follow these rules. This one a bit. Maybe some of you haven't seen this one before. Because SPM, you just need to convert. You no need to do add. Right? So degree level, we will all go into additional. So this one also inside your slides. It depends on what condition you have. On the first 2 columns is when you see 2 number. The right hand side, column 3, column 4 is when you have 3 number. So this 3 row, this number, if you see 1, right? 1 means you have the word carry. Means the first set, maybe you get 110 and you carry 1, right? And the number is covered to here. So later I will explain through the example. So let's do addition. Addition, you need to refer to that table, will be given in the test, also in the final exam. So let's say we add 2 binary number, 101 plus 1011. So how we do? So we do like this. You put the first number plus 10111. You arrange the number in this format. Then you draw a line. You work from the right hand side first. From right side, what you see? 1 plus 0, right? You go for the first 2 columns first. Go and find out which one is 1.0. 1 plus 0, 1. Carry 0. Okay. So you have this one. So in your sketch, you write index 0. Index 0 means the far right number. Index 0, 2 power 0 is 2 plus 1 equals 0, carry 0. Basically, you just copy this meaning into here. Then you continue to do. So, okay. Then you continue the second one. Okay. Second one will be 0, 1. Okay, you write out index 1, bracket 2, 1. 0 plus 1 equal, you read from here. 0 plus 1 equals 0. Carry 0. Okay. The third one, you continue. 0 plus 1. You write out index 2. Don't confuse this one. You start with 0, 1, 2. Then you write. The third one is 0 plus 1. Also same. 0 plus 1 carry 0. Okay, the fourth one. 1 plus 0. You look at here. 1 plus 0 carry 0. So you write out index 3, 2, 3, 1 plus 0 carry 0. Then the fourth number. 1 plus 0. You look into the table. 1 plus 0 carry 0. So you write here. Index 4, bracket 2 power 4. 1 plus 0, 1 carry 0. Then how you read? Okay. So there are no carry 1 here. So you don't need to read this side. Okay. So the answer is this one. You just read from here. I mean, read from the down one to there. Because index 4 is this one. Index 4, index 3, index 2, index 1, index 0. So you read from the back. Any question? No, okay. Okay, then how you check whether correct or not? How you check? So you check your number by using the table just now. This is index 1, 0, 1, 2, 3, 4. So 2 power 4 plus 2 power 3 plus 2 power 2, 2 power 1, 2 power 0. Does you get 9 or not? Okay. So you convert this one. You convert this one. Because this 0, 0, 1, 0, 0, 1 base 2 equal to 9. Right? If you base on the decimal table, binary table just now. Right? So 2 power 4, 0, 2 power 3, 1, and 0, 0, and 2 power 0, you get 9. Right? And this one you convert to a decimal also. So total is 31. Then you check your final answer, does it 31 or not? If yes, then this is the final answer. Okay, final answer means 1001 plus 1001 base 2. You addition, you get 111112. Yeah. Okay, if you understand this one, your revision. This one got carry 1. So let's say you have 11111 plus 10101. Let's observe what condition we use the column 3 and column 4. So the first, okay, in this example, I just want you to show you what is the difference between index 0, because some textbook you read, it will give you index 0, and some textbook give you bit. What does it mean? Index means location. Location number 0. Right, and so on. So this example will give you bit. See, I use bit. Bit 0 means also bit 0 means the number, the meaning of that number. Okay. So 1 plus 1 is carry 1. Okay. Now bit means actual binary digit, either is 0 or 1. If you use bit lah. But normal case, I will just encourage you to use index to be more easier. Unless you're communicating with computing people, then you use bit 0. Bit 0, bit 1, bit 2, bit 3, bit 4. Unless you're communicating with computing people, right? Or programming people. Okay. So let's continue. So Second is, you see, so the first one just now, 1 plus 1 is 0, but carry 1. Now you have carry 1. As long as you meet carry 1, you need to refer to another table already for the next number. So the next number is 1 plus 0. Okay, 1 plus 0, you need to, it's not here anymore because you have carry 1. So the next step for the next number, you need to read this one. So 1 plus 0, 1 plus 0, carry 1 from previous one. This one here, carry 1 equals 0, carry 1. Okay, understand now why this one? Why we refer to this one? So carry 1, if the previous one got carry 1, then the next one you need to read the another side, not the column 1, 2. You see, this the 1 plus 1, this one, you read the column 1 and 2. But when you move on to the second number, you need to move to another side already because previous one got carry 1. Okay. Yeah. This the third number here is actually carry, means carry. Means carry here. Okay. So now you know that the second number got carry 1. So you continue to use column 3 and 4. Here only like the first set you use this one. Yeah. So bit 2, you see this one, yellow color one. Bit 2 is 1 plus 1. 1 plus 1, but remember you carry 1 from the previous one. So you copy this one. 1 plus 1 plus carry 1 equal 1, then carry 1. Then what about the next one? So if you have carry 1, you continue to use column 3 and 4. Okay. So column 4, 1 plus 1, carry 1, 0, carry 1. So this one, 1, 0. So 1, 0, carry 1, equals 0, carry 1. So continue. So this one, 1 plus 1, carry 1. Yeah, this one. Yeah, this one. No, this one will be given. So we don't expect you to, this is 2, so we don't expect you to, we don't train you to memorize things actually, we train you to use tools. Okay. Yeah, so the next one is 1 plus 1 and so on. Okay, so you see the decimal and the bit a bit different. Bit, it means actual number, either 0 and 1. So here, how you read? Okay, now you have the, even you the last one, you got carry 1, right? So you need to read one more 1 in the answer. Okay, so how you do? So I just highlight the answer for you guys. So just now, bit 0, 1 plus 1 equals 0, you read the 0. You don't read the carry. You just read equal what? So number 2 1 equals 0. Number bit 2 or second, the third number is carry equal 1. Then equal 0, equal 1, but carry 1. So how many? The answer will be 1 1 0 1 0 0. This is how you read it. This is the final answer. Okay, so important you understand how to use the table. Then right. This one is to show you on bit, but most of the example I'll use index. I just use index, just not to confuse you. Okay. 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 So the extra carry to you write saja lah. Okay, this is just example. If you understand the previous one, I'll just move on. Okay. Okay, this one another same one. You go home and see. If you don't understand, come and ask me. Okay. Yes. Is in in test 1, usually you need to write index 0, what, carry what. You need to show me how you get that number. You need to write this one. For test 1, final exam maybe no need. Go final exam, I ask you more higher level question. Usually test 1 question a bit easy. So I try to find marks to give you carry some marks. Okay, if not, then people ask, hey, why this question you give 5 marks? So very hard for me to justify. I need to, if you write like this, then people will understand why this costs 5 marks, for example. More effort, more effort, more marks. Okay. Oops. Okay. These are example. Also, this is the third question for the third question. Third question for your exercise. Right. What mean by 3 by 3 time? 3 plus 3, you do the first two first, then you add another one. You do 2 set first. You do 2 set first, then you add another one. You repeat the same process. Because the table only allow you to solve 2 set number. So you cannot add 3, cannot. Yes, like for example, this one. Got 3 number. What you do the first 2 first, then only you add this one. Only because when you combine this one, you already get 1010 something. Then you use that number, continue calculate. Continue to add that number. Like this. So this one you can try out. The final answer is this one. Okay. Okay, binary okay. Okay. So now we go to octet. Octet means number 8. Similar concept like just now. Okay, if the number is a big number and you keep using number 2 base to represent, the process will be long. Like for example, this example, 1245. If you divide by 2, the step is very long. And if you are in computing, one step will consume energy or consume most of the calculation power. So this one will eat up all the memory in your computer. You need to store a lot of data there. So it's one is it takes longer time to process, and also is waste of energy also . So this is the octet number that I give you. I give you, right? So basically the same, like base 2. So the far right is 8 power 0, 8 power 1, 8 power 2, and so on. But we only do until 8 power 8 because it's too big already, the number. Too big already. Means 16 time lah. Okay. So if we have a big number, we'll use octet number. So we only use 0 until 7 to represent. Means the powers of the power number. Power 8 power 0 equal 1. The 0, 1, 2, 3 until 8. But here is octet number is 1 to 7. Okay, so just example. So if you have a 4317 octet number, you need to convert into decimal number base 10 so that the normal people understand what you are talking about. So that like here, like the same as the binary just now. Okay, you convert and then you write in here. So 43178 will be in equal to 2255 base 10. And you can see octet number is not 101010. It will be more than 10 digit. Mean it use 0 until 7 digit to represent the number. If you see 1010, that one usually base 2. So what happens if you want to convert a number, decimal number means base 10 number into 8. Same, if you want to convert base 10 number to binary, divide. So here also same. Okay, so something like this. So 493 divided by 8, you get 61, balance 5. Continue to divide until you get no more can go lah. Until you get the number is less than the 8. Then you stop there. Then you read from bottom to top. Okay, this one, like for example, 493 base 10 equal to 7558 by dividing the number with 8. This one is to change base 10 to octet number. Okay. Then the next will be change octet number back to decimal number. So this one you divide, change back, multiply lah. Okay, so fraction number, like for example, you got decimal one. Also multiply 8. So let's say we take 0.4375. Base 10, we want to convert into octet number. You multiply 8. Pull the balance of the decimal to the front. Multiply 8 until you get full number. Until you get full number, then you read from top to bottom. Remember, it's point something. This will be the careless mistakes. Sometimes you straight away you tell me the full number. Okay, it's 0.34 something. Okay, so here 0.34378 base 10 equal to 0.34 base 8. Okay, any question? What? Okay. So I give you a chart. We start to use chart already, so you don't need to memorize. So there is a table that give you octet number 0 to 7, and you can convert the digit 0 to 7 into 3-bit number. Means 3 numbers lah. 0, 0, 0 and 0 and number combination, 0 and 1 combination. Yeah. Okay, so how we use this table? For example, you are given octet number 4378. You need to convert to base 2. So again, you need to refer to the correct table. There are many tables in this chapter. This is octet digit to number. Later, there's one more table. Octet, binary, and decimal. So don't read the wrong table. So this one, 4437 means you go to 4, you copy the number. 4 equal to 100. Then you left out a space lah, just in case you don't want to confuse yourself. You just left a small space there. Means this 100 equal to 4. 3, you read from table, 011. 7 is 111. Then remember to write the 2 there lah, because 2 you read from the binary number, natural binary number. Okay, so this is decoding lah. Decoding in computer they call it encryption lah. Password encryption, like they put something into something, a converter, then it turn out something else. Okay. Okay, so this example, if I put like this, you should be able to understand. Right? 26.358, same also. 2, you refer to that table, 010. 6 is 110. Point, copy the point. Continue 3, 3 is 0.11. 5 is 0.010. Then remember to write the 2. Just read from the table. Only remember when you write in the test, it's a good practice that you have some small space for the number. For example, 2, 0, 1, 0, then have a small space for 6. If not, then in exam, you keep counting the number. Okay, so nothing complex here. If you see the set, the far left, you see 0, you don't need to write 0 actually. So if you give me this answer, also correct lah, also correct. But if you talk to a computer, people, it's a bit stupid mistakes if you write 0 in here. So the correct answer is like this: 26.38, and then you remove the 0 in the front and you give the answer. Of course, in test you accidentally write the 0 also, I give you correct lah. It's just that nobody write 0 in front of something, in front of the full number. No wrong you write so, it's just that not normal lah. Not normal, okay. Because in computer, you put in 1 digit there, you consume 1 space, your memory space there. Okay, so this is to convert x power 8 something to x2 lah. Okay, if you understand already, okay, this one is binary to octet. This one we skip lah, you know already. Okay, so this is a bit for your test kind of standard. It asks you to convert base 10 to binary number via octet system, octal. Meaning you need to convert 3714 power base 10 into something base 8, and from base 8 to base 2. Understand or not? If you see this kind of question via something, means you need to convert that number into octet first, then back to binary. 10, 8, 2. So there are two steps. One step is to convert 10 to 8, then 8 to 2. So yeah. Okay, so this is, if you understand the concept, this is just a illustration how you do lah. So 10 to 8, you mean divide. Okay, divide, then you get the first set answer. Use this 372028, convert to binary number. How? Use the table lah. 7 equal to 3 number, 3 either is 000 or 010 and something refer to table. So you got 1, 2, 3, 4. You got 12, 0 and 1 numbers. Okay. Sorry. Okay. So 7202 base 8 equal to, based on this number, you have 12 number here, base 2. Then, of course, the final answer, you don't stop here. Because I was waiting for your answer. Your answer should be, copy the question, 721410 equal the 2. Okay. So the careless mistake usually will be here. You divide something and then something, your brain play games with you. You suddenly I don't know, like 2 become 3 and you lost from there. And when you have some wrong number here, it will carry forward the mistakes. So sure wrong already, like if you wrong in the conversion here, the outcome of your number will be wrong. Especially those your handwriting one, 7. Some of you write very quick, it will be look like 1. So you read wrong in the answer. So some of you write 7 equal to like 9 kind of shape. You read wrong one. Okay. Okay, so if you understand this one, decimal, you know it's multiply. You multiply. So if you have a combination of full number and decimal, you need to do 2 times. One divide and multiply. Okay. So this one usually in the test, we want to see you working something. Because this one can test you your careless mistakes and so on. Because once you wrong in the conversion to octet, your final answer show wrong. Okay. So this is test your careless mistakes. Okay, we're done with the conversion. This one you can, I will post this one in the island, so you don't need to copy as long as you understand what's going on. Okay, so this one is a reverse back from base 2 to decimal base 2 to 8, then back to decimal. So how you read? Also you use the table. Use the table just now. You have 0, 1, 1, right? Refer to table, it means something. Okay. 0, 1, 1 means 3. Means the first 3 digit is 3. Then this one is 6, and so on. You just put this 3-bit number here, convert to this side. Then write the number. If you're lazy, you just write the number below the 3 number. Okay. So you have this one. Once you convert into 8, you have to convert back to power 10 number. So this is base 8. You want to put in the power 10, base 10. Means this is 3 is 8 power 2, 8 power 0. 8 power 0, 8 power 2, 8 power 3. And this one is minus 1, minus 2. Okay, like this. Okay, minimum, give me 3 meaningful number. Three meaningful number, meaning if you have 0.03125, 3 meaningful number is 313 at least. Okay, this is also your exercise. Any question? Okay, the last chapter, last section. Okay, hexadecimal. Hexadecimal, where do you see hexadecimal number? Your computer, color code, your camera, color code. You will see 6 number, color code in red, green, blue color. Each one will give you 2 digit, 2 digit, 2 digit. So let's say the yellow color is asterisk FFFF00. It's a combination of green, red, green, blue, you get yellow. For example, right? Okay. So this is just to let you know where do we use the hexadecimal number. So maybe some of you, when you reach your FYP, you do some photo analysis and so on, then you might use this one. Also related, it's just that for color code, hex code means it refer to color. Refer to color. So all the painting that have color one also refer to this color code. Okay, because our eyes, each of our eyes will see different color actually. So to be accurate, you need to define using digit so that the computer can give you the duplicate the correct color. Okay, so we are actually using this 0 to 9 and A to F. So total got 16 digit. Okay. So you also give you this chart. This chart you can read concurrently to convert hexadecimal into base 8, base 2, and also base 10. This actually, based on this, you can answer most of the questions. Okay. So how we use Okay. So from hexadecimal, if you are hexadecimal, you see 16 there below there, means it's a hexadecimal number. So if you have 1A to decimal number based on the table, or you can calculate by your hand. So the A means 16 power 0. The 1 is 16 power 1 because 0, 1. Okay, it have this meaning. Means the position of that number, the least position or least number is 0. Then 0, 1. So 16 power 1, 16 power 0. Yeah. Then you sum out the number, you get 26. Okay. So if you can refer to a table, you can straight away you get 26. Okay. Okay, converting to decimal also same. This one, if you understand already, this one, if you understand, this one also same. It's the same concept. Okay. Also same concept. Just the revision, what to do. Okay, now it's the conversion. Let's say I give you number 23. How we convert number 23 into base 2 based on the number. So 23, 2, right? 2 you read from here. If you want to binary, you read here 0, 0, 1, 0. But again, 0, 0 and in front have no meaning. Of course, you want to write 0, 0 here also can. Right? So 3 is here. 3 is 0, 0, 1, 1. So and so on. So I will show you how to do. Let's convert 7a into decimal equivalent. So this one you already know how to do. Right? Only the presentation when you write in the test is like this, 16 and 10. Okay, let's go to use table one. This one also. Okay, denary number means base 10. Denary number means base 10. Okay, so if you convert decimal to hexadecimal, also divide. He asks you to convert something to decimal, divide 16, to convert some decimal to binary, divide by 2, to octet, divide by 8, and so on. So let's say 26. As long as you divide until you get 1, you stop there. So in this case, 26 base 10 equal to 1a. So when you divide, the balance is 10, but in hexadecimal, there's no 10. Hexadecimal, no 10. Decimal, 10 is a. Because you only have 0 until 9, then continue a to f. Don't write 10. Don't write 1, 1, 0, 1, 1, 0, 16. It means something else. If you write 1, 1, 0, 16, it means something else. It do not belongs to 26. It means something else already. Okay. So this is also another example. So 15 is equal to f. 15 equal to f. So why 15? Because maximum division number is 16. Maximum you can balance is 15 or 16. 16 means you get 1. Okay, so 447 equal to f 1 fb, 1 bf 16. Make sense? Okay. The rest, if you understand already, I'll just go fast. If you convert, just divide, right? Convert, just divide. If you see decimal, you just multiply. Okay, this is your another example homework to do. Answer is there already. You can check, but this one I give tip the answer. Okay, the next one will be conversion. So sometime in the exam, I will not space a number for you, but I will just lump out just to trick you. Sometimes you are bad in counting, so maybe you give me a wrong answer. So once you see the number in the test, in the binary number, the first step is to space them. Space them into 4-bit. Okay, into 4-bit means hexadecimal 4-bit. Then 1110 you read from the table is equal to E. Then 10111 equals 7 and so on. This one from the table. Okay. Okay. So the table actually is for 4-bit. It's a 4-bit number. Don't read the wrong table. Octet to binary is 3000. But from octet to hexadecimal and that one is 4. Then binary, no choice. You have to divide or multiply. Yeah, so just a quick, this one, you should be able to find this number, right? 1101 is what? 1101 is what? In the table? 1101 is D. B. B or D? Okay. Okay. 0110 is E. 6. Okay. Then the answer is D6. This the final answer is this. No complex. No different. No, not very challenging. Okay, the rest you read. Got problem or got question, can ask me. Decimal to binary also from the table. For example, you are given 11111 something base 2. You just go to the binary column, read back the hexadecimal number. Yeah. So 11110, you go and find out equal to 6. No. Is it correct? Oh no. E is 11110. Okay. Because this one E you go and find E. E is 11110. Then put here. Then 7. Go and find 7, put here, and so on. So 6 is here. Is 01110. And again, 0 doesn't carry any meaning. Yeah. So 6 is here, C is here, F is this one, 3 is this one. Okay, if you understand, then we can go fast. Understand? 3 become this one, F become this one from the table. Important is how you report your answer. Sometimes you are too lazy, you write 3F equal 11111. I put question mark. What is this? You need to tell me from what base to what base. Okay, I think you understand already. We go for the last slide if we have any. Okay, this is your homework also. Okay, with this we conclude chapter 2. Any question? Okay, Noah. Okay. Yes. Next week?